This is questions 6 and 9 in exercise 16.1 in Project Maths 2. So, given that the tan of Q is equal to C over D, we have to label the angle Q in the diagram. So let's just recap real quick how we calculate sine, cos and tan. So sine, cos and tan. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. So we've been given the tan of an angle. It's C over D, and we're looking for to choose which angle that will fit in where the opposite side to that angle is C and the adjacent side to it is D. So that means that we're going to have Q marked. This is the top up here, like that. So that's the angle Q, and that's part 1. Now for part 2, we have to express cos Q and sine Q as simple fractions. So I'll start with cos Q. So as we said over here, cos is adjacent over hypotenuse. The side adjacent to Q in this diagram is D. So it's going to be D over, and our hypotenuse in this diagram is X. So it's D over X. And then for the sine of Q, we're looking for the opposite side to the angle, which is going to be C. And then that's going to go over the hypotenuse in the triangle, which is X. So that is question 6 done. Let's take a look at question 9. Okay, in question 9, we're told that the sine of theta is 7 over 25, where theta is between 0 and 90 degrees. We've got to first find as fractions the value of cos theta and the value of tan theta, and then we have to show that cos squared theta plus sine squared theta is equal to 1. That's straightforward enough. In order to get our value for the sine or the cos and tan of this, we're going to have to first of all find out what the third side in the right angle triangle formed by this is going to look like. So we'll draw a triangle just to start with first. We'll mark theta down here, like that. Now remember, as we said above, that sine is opposite over hypotenuse, which means in this triangle, the opposite side will be 7 over here, and the hypotenuse is going to be this side just here. And we'll call this unknown side down here X. And we need to get a value for X in order to get the cos and tan of theta for this. So for that, we're going to go with using Pythagoras theorem. We're going to say 25 squared is equal to X squared plus 7 squared. 25 squared is 625. X squared is X squared. And 7 squared is 49. Which means that 625 minus 49 is equal to X squared. So X squared is equal to 576. Which means that X is equal to the root of 576. So X is equal to 24. So now that we've got our value for X, we can use that number to get our value for cos theta and tan theta. So cos is adjacent over hypotenuse. We found out that the adjacent side is equal to 24. So the cos of theta is going to be 24 over 25. And then for the tan of theta, we know that tan is opposite over adjacent. Our opposite is 7, our adjacent is 24, so it's just going to be 7 over 24, like that. So that's how we could do part 1. Part 2, despite looking a bit awkward, is actually relatively straightforward. The reason for that is that cos squared theta is just equal to the cos of theta all squared. In other words, the value that you get when you get the cos of theta and you just square it, and that's how you get cos squared theta. So when we say we want to check that cos squared theta plus sine squared theta is equal to 1, we're going to sub in the values for that. Since cos is 24 over 25, we're going to have 24 over 25 squared plus sine theta, which we already know from because it was given in the question, which is 7 over 25 squared. And we're just checking that that is equal to 1. Well, 24 squared is 576. 25 squared is 625. And then 7 squared is 49. And as we said before, 25 squared is 625. And when you add the two of them together, you're just going to get 625 over 625, which is equal to 1. Which is equal to 1. Anything divided by itself is equal to 1. So that is us having shown that cos squared theta plus sine squared theta is equal to 1. And that is that.